Okay, so in this section, we're going to start putting our relationships of mass to moles to work with our chemical equations. So if we've got a chemical equation written up here, we've got C2H6 combining with 6 Cl2 molecules to produce 1 molecule of C2Cl6 and 6 molecules of HCl. So that would be at the small scale. But remember, our coefficients also correspond to the number of moles that are going to be present. So we can also say that 1 mole of this is going to combine with 6 moles of this to give us 1 mole of this and 6 moles of this. So essentially, we've got a recipe in our chemical equation of how much to add. Only we can't measure out a mole of this substance very easily because we can't count the number of molecules to get 6.02 times 10 to the 23rd molecules of that substance out. So we've got to be able to convert it to grams. And I accidentally put parentheses in here, but this should be grams in our question. So I want to know how many grams of chlorine gas must react to produce 1.2 moles of our product over here, our C2Cl6. So we can do this because we have mole relationships within our reaction that are going to help guide us. We know how many moles it's going to take to get 1 mole of this, right? It's going to take 6 moles of our chlorine gas to get to 1 mole of our product. So we can calculate then how many moles of our chlorine gas it's going to take to produce 1.2 moles. That's not going to be very hard. That's just going to use our ratio as a conversion factor. And if we can calculate the number of moles of chlorine gas that we have, we can also calculate the grams of chlorine gas that we have by doing our simple grams to moles conversions that we've been practicing. So let's go ahead and set this question up. So we want to find, right, we want to find the number of grams of chlorine gas. So we want grams of Cl2. That's what we want to end up finding. So what do we start with? We're going to start with 1.2 moles of C2Cl6. So when we get to looking at our equations, I think it's very useful to write the equation in, to write your formula in next to whatever you've got so that you remember what you're talking about. So I'm going to put the C2Cl6 next to my moles because that's the moles of that compound. Now we know our ratio here is going to be 6 moles of Cl2 gas for every 1 mole of C2Cl6 produced. So we can multiply this, and this is our conversion factor then between moles of C2Cl6 and moles of Cl2 gas. So our moles of the C2Cl6 is going to cancel out, and then we can calculate this out to find the moles of Cl2 gas or chlorine gas that we have present. So 1.2 times 6 is going to equal 7.2 moles of Cl2 gas. But that's not what we want, right? No, we want the grams of Cl2. We don't want moles of Cl2. So we have to do one more conversion. But this is going to be an easy conversion, right? Because we know how to calculate and go between grams and moles. We need to know the molar mass of our formula up here. So now we're going to start out with 7.2 moles of Cl2 gas. And we're going to have to multiply this by our conversion factor. So we're going to want grams on top because that's what we want to end up finding over 1 mole. So we need to calculate the molar mass of Cl2. So that's going to be 2 times 35, essentially. Or that's going to be 70 grams. So we can put that into our equation up here. And we can calculate how many grams of Cl2 gas we're going to need for 7.2 moles of that gas. So for this reaction to happen, we would end up needing 504 grams of Cl2 gas. And that would be our answer for that problem.